Hi everybody, welcome to our YouTube channel Maths Insights. In this video, I am going to start a new topic called Binomial Theorem. This Binomial Theorem is in class 11 of CBSE syllabus and it is the chapter number 8. We will discuss video by video the total topic related to Binomial Theorem. Shall we? In this discussion, we are going to discuss binomial theorem in detail. So, the subtopics are which we are going to learn are what is meant by a binomial, then Pascal triangle, then you will know how to expand a binomial. In the binomial expansion, you have to observe some points which are very useful in solving the problems. And after that, we will solve some problems on the topics, on the concepts which you learnt in this video. Now, I will explain you what is meant by a binomial. The name itself says bi means two. Any expression which contains two dissimilar terms, very important, two dissimilar terms which are separated by either plus or minus is called a binomial. I will take an example x plus y whole square and also a plus b whole square. You may have written the formulas for this number of times in your previous classes, is it or not? It's very easy also. Here x and y are dissimilar terms, a and b are also dissimilar and they are separated by plus. Otherwise you may write x minus y also, x minus y whole square also. This is called a binomial. Now, how to expand binomial is very important. You know how to expand x plus y whole square. X plus y whole square is equals to x square plus 2xy plus y square. You may have written that number of times in your previous classes, but you may have written that in the order of x square plus y square plus 2xy, or in case of a plus b whole square, a square plus b square plus 2ab, but that is not the correct order. The correct order is a square plus 2ab plus b square, or in the case of x plus y whole square, it is x square plus 2xy plus y square. Now I am expanding all this up to some extent. I am taking x plus y whole power 0. See, the first one is x plus y whole power 0. Anything power 0 is 1. You know all about this. But the sum of this x and y should not be 0. Why? Because if the sum of x plus y becomes 0, this will become 0 power 0, which is undefined. 0 power 0 is undefined, but except 0 power 0, anything power 0 is 1. That's why I am particularly mentioning that x plus y value should not be 0. Then next I am taking x plus y whole power 1. Then it will be x plus y itself. Now if you take x plus y whole square, this will become x square plus 2xy plus y square. And if you take x plus y whole cube, x cube plus 3x square y plus 3xy square plus y cube. Similarly, if you take x plus y whole power 4 also, you can expand it. But when the power or index of the binomial increases, it will become difficult to expand it. Is it or not? See, a plus b whole power 20. Can you expand it easily? Definitely not. but it is not impossible, it is possible but difficult. So to overcome this difficulty in expanding the binomials of higher indices, you have to learn the binomial theorem. Okay, now you may observe what is the coefficient of this is 1. Okay, and if you observe, the coefficient of x is 1, here is 1, I am writing 1 1. See, when the index is 0, see, this is called index. In this binomial expansion, we are confining our discussion to the power of positive integers. For the binomial, we are taking only positive integers in this chapter. We will discuss remaining in the remaining chapters. See, 0 is neither a positive nor a negative number. So, except 0, all are positive integers. So, I am taking 1, 2, 3, 4, 5 and so on. You may take whatever the number you like. If the index of the binomial is 1, see, this is the index of the binomial. If you observe the coefficient of x, coefficient is the number which is multiplied by the variable. Here the variable is x, x is multiplied by 1, y is multiplied by 1. So I am writing only coefficients to explain something. Next, when the index of the binomial is 2, there will be 3 terms and the coefficient of this one is 1, and the second term, the coefficient of second term is 2, and the third term y square is 1. If here you don't have anything, you may write 1. Similarly, if the index of the binomial is 3, you have the coefficients as, see, x cube is having only 1 as its coefficient, x square y 3, this is also 3, this is also 1. If you write all these coefficients, are you observing any relation between the rows? Definitely we will have relation. If you start one and at the end of every row, starting and ending, extremes, at the extremes of every binomial expansion, you will have coefficients as 1 1 1 1 1 1. Now if you observe, if you add 1 plus 1, you will get 2, and also if you add 2 plus 1, 3, 1 plus 2, 3, in the extremes 1 and 1. Now if you want to get the coefficients of the binomial with index 4, it's very simple. See, this is 1 plus 3 4, and this is 3 plus 3 6, and this is 3 plus 1 4. You know that extremes will have the 1 as their coefficient. In this way, whatever the power, whatever the index may be, you can find the coefficients of the terms. See, it is appearing like a triangle. This is called Pascal triangle. Pascal is a name of a scientist who designed a triangle for writing the coefficients of a binomial expansion. By using these coefficients, you may expand the binomials, whatever the power may be, but it is somewhat difficult. Blaise Pascal is a French scientist who discovered this one. So you know that if the index of the binomial increases, it will become difficult to expand the binomial by using Pascal's triangle. I will expand 1 by using this Pascal triangle by using the coefficients. See, if you take x plus y whole power 4, I have written already when the index is 4, the coefficients are 1 4 6 4 1. Okay, 1 4 6 4 1. So this is plus 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 plus. And in the expansion, the first term x will have the index as the index of the binomial. Whatever the index of the binomial, the first term will have that power, x power 4, and the second will have 0. In the coming terms, in the consequent terms, the index of x will decrease by 1, 1, 1, and the index of y will increase 1 by 1. In the next one, you may know that x cube y power 1. 4 when reduced by 1 becomes 3, and 0 when increased by 1 will become 1. Similarly, this is x square y square. Next, x power 1 y power 3, x power 0 y power 4. So, is it easy to expand by using this Pascal triangle? But up to some extent, even when the index of the binomial is 10, you can expand by using the coefficients, but when the index increases, it is difficult. So, we will learn how to expand the binomial by using binomial theorem. To explain my binomial expansion, I am taking the example a plus b whole power n. With this, I will explain how to expand the binomial. Now, before this, I want to explain one more concept, that is the concept of combinations. See, combinations NCR is equals to n factorial by r factorial into n minus r factorial. This is the another concept called factorial. See, factorial of a number 5 is written as 5 factorial. It may be like exclamatory symbol. Starting with 5, you have to multiply this number with the natural numbers by reducing 1 by 1 in the next consecutive products. See, 5 into 4 into 3 into 2 into 1. Then the result of this product is called 5 factorial. Now, I will explain this concept of combination very easily with an example. Suppose in a bag there are 3 balls of different colors. Now, I want to pick up 2 balls at a time without seeing into the bag. So, question is, how many possibilities are there? See, you cannot expect which colors you can pick. So, that is the way how to find the number of possibilities by using the concept of combinations. Suppose if you write 3C2, this is the number of balls in the bag. There are 3 balls and I am picking up 2 balls at a time. Then how many possibilities are there? Let their colors may be red, blue, green. Without seeing the colors of the balls, you have to put your hand into the bag and pick up 2 balls. Can you say what are the colors of the balls? Definitely you cannot say. Why? Because there may be a red and blue, or there may be blue and green, or there may be red and green. Red and green, this is the possibility. Question is, how many possibilities are there if 3 different balls are placed in a bag and picking 2 balls at a time. So, to write, that means if you write 4C3 means there are 4 balls in the bag, you are taking 3 at a time, then how many possibilities are there? See, here I am taking 3C2 means in my bag there are 3 balls, I am taking 2 at a time, then there are 3 possibilities. This is one possibility, second possibility, third possibility. Now, when the balls are in lesser number, it is very easy to explain like this, but when the number of balls are more in the bag, suppose 20 balls, is it easy? Definitely not. So, you have to learn a formula, how to find the number of possibilities. So, that is the formula. See, 3C2 means n is 3 here, r is 2 here, right my dear students. Now 3 factorial by r factorial means 2 factorial and n minus r factorial 3 minus 2 factorial. So you know what is 3 factorial. Starting with the 3 you have to reduce 1 and multiply it until you get 1. So 3 into 2 into 1 by 2 factorial is again 2 into 1. 3 minus 2 1 factorial means 1. So 2 1 2 1, so 3. 3 is the number, means there are 3 possibilities if you pick 2 balls at a time by placing 3 balls in the bag. Okay, you understand? Now you can have this in our binomial expansion. That's why I explained this. Here in this NCR, this r value is always starting with 0 and ending with n. Means if you have 3 balls, you may take 3 balls at a time maximum. Can you pick 4 balls at a time if you have only 3 balls in the bag? Definitely not possible. So this r value should not be more than this, means this r value starts with 0. That means 0 means you are not picking any balls. That is also one possibility. If you are not picking, that is also one possibility. So 0 factorial is 1. You have to keep in your mind. 0 factorial is 1, not 0. 0 factorial is 1. We will learn these in detail in the coming chapters, which are particularly for them. Okay. Now coming to our binomial expansion. Before expanding this, I will take one example, that is a plus b whole cube, right? A plus b whole cube. You know that this is a cube plus 3a square b plus 3ab square plus b cube. I already said that the index of the first term in its first term is 3, which is equals to the index of the binomial. Then its value decreases by minus 1 minus 1 minus 1 and finally its power will become 0. And in the first term the index of the second term is 0, and these are called coefficients, right? So first I will write coefficients in the form of combinations. Okay, see I am starting with NC0 into a power n into b power 0. See, this is the first term, so the index of the first term is n, which is the index of the binomial, and the index of this b is 0, then increases its index. Now this NC0 is coefficient, which is equals to 1. Then NC1 into a power n minus 1 into b power 1. The index of a will decrease a power n minus 1. This index will increase. 0 plus 1 is 0 plus NC2 a power n minus 2 into b power 2. And finally, if you expand like this, in the final term you will have NCN. NCN, you have to stop here. NC0 starting, NCN is the last. These and these should be equal, then you have to stop. And the index of the first term will become 0 and the index of the second term will equal to the index of the binomial. This is the binomial expansion of binomial a plus b whole power n. Here NC0 comma NC1 comma NC2 and so on NCN are called binomial coefficients. Is it or not? All of you know, in this case also you have coefficients, and you know how to expand, how to find the values of NC0, NC1, NC2 and so on NCN. I will make it very clear by taking an example. Don't worry, I am here. I will make it very easy, right? Come and take the example. This is my example, that is a plus b whole power 5. In the place of b I am taking 2 and writing a as it is. You know that you have to start with 5c0, okay? 5c0 plus 5c1 plus 5c2 plus 5c3 plus 5c4 plus 5c5 over. When you get 5 equal, then that is the last term, right? These are the coefficients. I have written all the coefficients. Now I am going to write the terms. You know, in the first one, the index of the first one is equals to index of the binomial, therefore it is a power 5 and 2 power 0. In the next consequent terms, the index of a will decrease by 1 term by term. So a power 4 and its value increases a power 1. See, 2 power 1. Next, a cube 2 square, a power 2 2 cube, okay? A power 1 2 power 4, right? A power 0 2 power 5. Expansion is over. It's very simple if you know the binomial expansion, right? Now you have to know the values of these coefficients by using this formula. NCR is equals to n factorial by r factorial into n minus r factorial. You know, you come across that in the Pascal triangle, the extremes, the coefficients of extreme terms, that means first term and last term, the coefficients are always 1. Therefore 5c0 is equals to 5c5 is equals to 1. So from this you may learn that nc0 is equals to ncn is equals to 1, definitely, okay? From this you may learn that ncr is equals to ncn minus r, value equal, but it is not equal 1. When it is 0, this value is always 1, and when these two are equal, its value also equal. NCR is equals to NCN minus R. For example, I am taking 5C2 value is equals to 5C3 value. You will find its value. What is the value we don't know, but the coefficients 5C2 and 5C3 will have same values. Why? Because if you find this is 5 factorial NCR by 2 factorial into 3 factorial. If you see this also 5 factorial by 3 factorial into 2 factorial n minus r. So both are same, but we don't know what is that value. 5 factorial means 5 into 4 into 3. I will stop up to 3 factorial. Why? Because my dear students, here in the denominator you have 3 factorial. I will cancel that. That's why I will not write until end. So 2 factorial is to be written as 2, 3 factorial, 3 factorial, 3 factorial cancel. Therefore 2 ones are 2 twos are. So its value is 10. So both are having both the coefficients 5c2 and 5c3 will have the same value, that is equals to 10. So in this manner you will find the values of all the coefficients. After finding its values, we will expand it very easily. Is it becoming easy? Yes. Now we will learn how to write it. See, 5c0 is 1, you know, 1 into a power 5. So 2 power 0 is 1, not required to write, plus 5c1. If you calculate 5c1, its value will become 5 factorial by, okay, 1 factorial into 5 minus 4 is 4 factorial. So its value will become 5 into 4 factorial by 4 factorial. 1 factorial is 1, 4 factorial cancel. So answer is 5. So 5c1 is 5. 5 into a power 4, 2 power 1 is 2. Similarly 5c2, I already calculated 5c2 value and 5c3 value are equal, which is equals to 10. Therefore 10 a cube into 2 square means 4. 5c3 value is also 10 plus 10 a square 2 cube is 8 plus 5c4 and 5c1. If the difference of this and this is having here, then those values are equal. 5 minus 4 is 1, 5 minus 1 is 4, so both are equal. That value is also equals to 5, a 2 power 4 is 16, and finally 5c5 you know 1. The last term will have its coefficient as 1. So 1 into a power 0 is 1, 2 power 5 is 32. So this is the expansion. I will write it. A power 5 into 1 is a power 5 plus 2 into 5 10, 10 into a power 4 plus 10 fours are 40 into a cube plus 10 into 8 80 a square plus, okay, 16 5s are 80 a plus 32. So this is the expansion of a plus 2 whole power 5 by using binomial theorem. Is it easy or not? Definitely it will become easy if you solve 2 or more problems, right? After this we will observe some points from this expansion. I have written the expansion only without writing all this. I erased those. Now the first point, observations, okay, observations in the binomial expansion. The first point is the number of terms in the expansion are 1 more than the index of the binomial. See, what is the index of the binomial here? 5. Means you will have 6. This is 1, 2, 3, 4, 5, 6. Similarly, if index is n, then there are n plus 1 terms in the expansion. Very, very important, right? And the second point is, in each term, if you observe, in each term, the indices of both the terms is equal to index of the binomial. See, I calculated it by mixing 2. So when you combine 2 power and a power, those will become equal to 5. See, this is 5. Why? Because there was 2 power 0 also. 0 plus 5 is 5. Similarly, you come across this as, see, this is 5 into actually a power 4 into 2 power 1. We multiplied this and made 10. So this is the first term and this is second term. The index of this one is 4 and this one is 1. 4 plus 1 will become 5. Similarly, in this also you have multiplied it. See, a cube into 2 square into 4, 10. Here also 10. A cube 3 plus 2. The index of the first term, the index of the second term. If you add those two, it will equal to the index of the binomial. Is it becoming clear? In every term, okay, in every term, the sum of indices of two terms, okay, is equals to n. What is n? N is the index of the binomial. If you observe here in this, n plus 0, n minus 1 plus 1. Minus 1 plus 1 will get cancelled, again you will get n minus 2 plus 2. Minus 2 plus 2 will get cancelled, then again you will get n. Wherever, whatever the term, if you observe that the indices of, if you add the indices of both terms, that will be equal to the index of the binomial. And third one is, if you observe, the coefficient of the term at the first place and the last place is 1. All of you know that. Is it or not? So these are the main points, and you come across that NC 0 is equals to NC, 1 is equals to NC1, NC0 is equals to NC, N is equals to 1, and also NC1 is equals to N. 5C1 you have written 5, okay, and NCR is equals to NCN minus R. You have taken one example, 5C2 is equals to 5C3. So in the expansion, if you calculate the values of some coefficients, then they are enough to write the remaining coefficients. Okay. Now basing on this, we will have two problems, then this expansion will become very easy. This is the first example. See, 11 power 5. Of course you know what is meant by 11 power 5. When 11 is multiplied 5 times, you will get the value. But by using the concept of binomial theorem, we have to find the value of 11 square. So how it will be? See, I will write 11 as 10 plus 1 whole power 5. Means, even though they didn't give you binomial, I will make it a binomial. And take care that one of your term should be 1. Why? Because whatever the power to 1, that will become again 1. That's why I am advising you, if you want to make a binomial, then make one of the terms 1. See, then as per our discussion how to expand a binomial, see, you have to write 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5. Right, my dear students? Yes. Now the first one is 10, therefore 10 power will become 5 and 1 power 0, 10 power 4, 1 power 1, 10 cube 1 power 2, 10 square 1 power 3, 10 power 1 1 power 4, 10 power 0 1 power 5. If you observe in the each term, 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, 0 plus 5 is also 4. Yes, is it? Now, you know the coefficient of the first and last terms is 1. Therefore, 5C0 value or 5C5 value is 1. And also, this 5C1 value is 5. Why? Because NC1 is N. Similarly, you calculated already 5C2, 5C3 values are 10. Okay. Now 5C0 is 1, therefore 10 power 5. So after writing 1, you have to write 5 zeros, which is equals to 1 lakh, and 1 power 0 is 1. 5C1 is 5, 10 power 4 means this is 10,000 and 1 power. 5C2 value is 10, 10 cube is 1000, okay, and 1 power 2 is again 1. 5C3 is also 10 into 10 square is 100 plus 5C4. 5C4 or 5C1. Why? Because 5 minus 1 is 4. 5 minus 4 is 1. Therefore, as per our formula, NCR is equals to NCN minus R. The values are equal. Therefore, 5C4 is again 5 into 10, okay, plus 5C5 is 1 again. 10 power 0 is 1, 1 power 5 is 1. So this is the expansion. See, 1 lakh, 5 zeros plus this is 50,000, right, plus 10,000 plus 1000 plus 50 plus 1. So it's very easy. 1. So 1, this is 5, this is 0, this is 1, this is 6, 1. So 1,61,051. This is the answer. Okay, without confusion, I am adding all this. Then your answer is 1,61,051 is the value of 11 power 5 if you expand, if you find its value by using binomial theorem. Okay, shall we take another one? This is the next problem which you are going to solve by using binomial theorem. Shall we? Right. See, the index is 4, so there will be 4 plus 1 terms, 5 terms. So starting with 4, 4c0 plus 4c1 plus 4c2 plus 4c3 plus 4c4, that is the last one. So first term is y power 4 into 1 by x square whole power 0. Right, my dear students. Next is y cube 1 by x square whole power 1. Next y square 1 by x square whole power 2. Next y power 1 1 by x square, actually this is 1 by x square 3. Next y power 0 1 by x square whole power 4. Actually this has to be done as per the expansion formula, nc0 into x power n minus 1 into y power 0, like that. But I am writing the coefficients first, then writing the terms. 4c0, you know 4c0 is equals to 4c4 is equals to 1, and also 4c1 is equals to 4, right or not? See, what is 4c2? 4c2 is 4 factorial by 2 factorial into 2 factorial. Again, see, this is 4 into 3 into 2 factorial. 2 factorial is 2 into 2 factorial. See, 1 2 factorial I am calculating 2 into 1 as 2. Remaining is writing as it is. Why? Because I stopped at 2 factorial while expanding 4 factorial. Why? Because to get cancel these two. So if you cancel this, 2 ones are 2 twos are, the coefficient value is 6. Therefore 4c2 is equals to 6. Now y power 4, 4c0 is 1. So y power 4, anything power 0 is 1, plus 4c1 is 4, y cube into 1 by x square, plus 4c2 value you calculated as 6, y square by x power 4. See, x power 2 and 2, a power m whole power n will become a power m into n, 2 into 2 is 4. Therefore next one is 4c3. You calculated 4c1, 4c1 value is equals to 4c3 also. Why? Because ncr is equals to ncn minus r. The difference of 4 and 3 is 1. The difference of 4 and 1 is 3. 4 and 1, 3 you are getting here. The difference of 4 and 3 you are getting here. When you get like that, those values will become equal. So whatever 4c1, that is 4, that will become 4, y power 1 into 1 by x power 6. Right, my dear students? 4c4 is 1, again y power 0 is 1, again 1 by x power 8. Now if you write it, y power 4 plus 4y cube by x square plus 6y square by x power 4 plus 4y by x power 6 plus 1 by x power 8. So this is the expansion of the given problem. I think you understand what is meant by a binomial Pascal triangle and how to expand, what are the coefficients. Everything is clear. You solve 2 problems also. In the next video, we will solve more problems based on these concepts. If you like my video, don't forget to subscribe it, like it. We will meet in the next video with more problems based on the concepts which we discussed here. Okay? Until then, have a nice day. Be safe, be indoor, take care of you and your family. Thank you very much for spending your valuable time. Have a nice day.